So for question 6, it is known that the static friction force between the small block B and the plate will be exceeded and the block will start sliding on the plate. So this small block over here, this point B is the block, and it's rotating on this this plate in some sense. And when the total acceleration experienced by this B reaches 4 meters per second square, and this B will start to slip a bit. Okay, it will start to slip. If the plate starts from rest at t equals to 0 and is accelerated at a constant rate of 5 radians per second square, determine the time t and angular velocity of the plate when the block starts sliding, assuming the radius, this r over here, is 250 mm. Now we write down whatever that we have received from the question, so we know that the angular acceleration is 5 and it is constant. And since this is a constant acceleration formula, I am able to use the kinematics equation, which is over here. Omega f equals to omega initial plus alpha t. I sub in all the values that I have because I know that it starts from rest. That means initially there's no angular velocity, hence omega I is 0. Then I sub 5 into alpha and I get omega final equals to 5t. However, I have two unknowns and only one equation. So to solve for these two unknowns, I need one more equation. The acceleration can be broken in two parts, the tangential acceleration and the normal acceleration. Tangential acceleration is just 5, which is the angular acceleration, crossed with the radius, and I will get 1.25 meters per second square in the negative I direction. And the normal acceleration is just the centripetal acceleration, which is negative r omega square equals to negative 0.25 omega square. I don't know what is omega, but I leave it as it is. Just to know that this is a pure circular motion, hence there's only tangential acceleration and the centripetal acceleration. If it's a curvilinear motion, there'll be a Coriolis acceleration and a linear acceleration, but you do not worry about that for now. We have yet to touch curvilinear motion. Once we have it over here, we can take the absolute values of these two and I can solve for omega because I know that it will not exceed 4 meters per second square. And over here, I can solve for omega, and omega is 3.8985 radian per second. And with omega, I can solve for t because now I have one of the unknowns solved. I can sub into equation 1, I can solve for t, and t I'll have 0.7797 seconds.